This is Honors Algebra 2 Pre-Calc. We're doing partial fraction decomposition, which is section 2.7 in the Pre-Calc book, but is part of our chapter 6 / partial fractions unit. All right, so if we have an improper fraction, meaning the numerator degree is greater than or equal to the denominator degree, then we have to divide first and do partial fractions decomposition on essentially the leftovers. So let's walk through an example of that. So here I have x cubed minus x squared minus 2x minus 28 all on top of an x squared minus 2x minus 8. Well, the thing is that this degree is higher than this degree, and if this degree is greater than or equal to this degree, so if this had been a 2 or higher, I would have to divide before I can do anything else. So that's what we're going to do. So before I can do this, I'm going to have to go over here and actually divide this guy. So because this is a nonlinear divisor, I'm going to use long division. In general, the only time synthetic division is faster is if you're dividing by a linear divisor. It's not that it's impossible to do synthetic division here, it's just that it would be a mistake. So I would suggest that you avoid it. In high school, I believe that maybe my pre-calc teacher told me it was impossible to do synthetic division with nonlinear divisors, and I didn't think impossible was likely true, so I tried it, and what she should have said was it's heinous and terrible and disgusting, but it's not impossible. So it works, it just works horribly with a lot of caveats. Okay, so I'm going to do long division here, right? I'm trying to figure out what I have to do to x squared to get an x cubed, and that is multiply it by x. I then distribute the x to everybody else in the car, right? This is the driver, and whatever the driver does, everybody else has to do it too. So I end up getting an x cubed minus a 2x squared minus an 8x, right? And I'm going to subtract straight down, just like we always do in division. So the x cubed minus x cubed is gone, which is the whole point. The negative x squared minus a negative 2 would become a plus 2. So I'm going to get an x squared, right? The negative 2x minus the negative 8 would become a plus 8, right? So I'm going to get a plus 6x, and then I'm going to drop this minus 28 all the way down, right? Then I'm going to play the same game again and say, cool, what do I have to do? Oh, my bad. What do I have to do to this leading term to make it look like this? And the answer is times it by a plus 1. So I'm going to get an x squared minus a 2x minus an 8, and I'm going to subtract straight down. The x squared minus x squared goes away. The 6x minus the negative 2 becomes an 8x, right? The negative 28 minus a negative 8 becomes a negative 28 plus an 8, which is a negative 20, and this is my remainder. The reason I know to stop is because this function right here has a smaller degree than this function, right? So that's my remainder. So essentially, after all that work, what that means is that I can actually rewrite this guy over here as the x plus 1 plus the remainder, which is the 8x minus 20, over my divisor, which is the x squared minus 2x minus 8. So here's what I want you to notice, okay? This is the thing that we have to decomp, all right? Partial fraction decomp. But when we do it, we have to remember that at the front of that thing, right? So at the front of that thing that we're going to do the decomposition for, we have to remember, oh, hey, there was an x plus 1 that whole time, right? So I'm going to remember that my answer is going to include an x plus 1 plus whatever decomposition I end up with. But the x plus 1 is no longer part of the actual decomposition. So I'm going to separately go ahead and do the partial fraction decomposition now. So what I want to do a partial fractions decomposition for is not the original. It's for this 8x minus 20 over an x squared minus 2x minus 8, right? So I'm going to erase my division because we already did it, right? So when I go to do this decomposition, right, and actually I should probably inch this way and move that whole guy over here because that'll buy me some more space. So I'm going to go ahead and do my partial fractions decomposition, right? The thing I want to do the decomposition for is only, as I said, this 8x minus 20 on top of this x squared minus 2x minus 8. Now remember, first rule is when you're doing a decomposition, you have to factor the denominator fully. So this is an x minus 4 times an x plus 2. And that's the way I'm going to consider that denominator from here on out, right? So that's going to be equal to an a on top of an x minus 4 because it's a linear factor, so it's a constant numerator, over a b times an x plus 2, right? So this is one of those nice friendly problems where when I go to find my common denominator, I realize that the x minus 4 is only missing the x plus 2, right? And the x plus 2 is only missing the x minus 4. So this is actually a pretty friendly problem once you get past the annoying part about it being an improper fraction to begin with. So when I look at my numerators only, right, I end up getting 8x minus 20 equals a times the quantity x plus 2, plus b times the quantity x minus 4, and I know that 2 rounds of clever substitution are going to knock out what I need to knock out, and I'll be able to find this answer pretty quickly. So I'm going to start by cleverly substituting in a negative 2 for x, which will knock out a. So if I substitute x equals negative 2, I get a negative 16 minus a 20 equals a 0, plus a b times a negative 6. So I get negative 36 equals negative 6b, which gives me, if I just draw an arrow over here, b equals 6. Great, so I now have my b, right? And then if I do my other substitution, if instead I substitute in an x equals 4, right, which I'm going to inch a little bit this way and do, if I substitute in an x equals 4, that's going to knock out my b term, so I'm going to end up getting 32 minus 20 equals a times a 6, right, because b was 4, so 6. So I end up getting 12 equals 6a, so my a is 2, right? Now, I'm not going to do this one both ways. I'm just going to do this one using the clever sub. You could have done it either way, but I'm going to point out that the clever sub is probably faster. So then what's going to happen is I'm going to go back up to this work, right? And when I go to get my answer, it's important that my answer remembers that, oh, hey, I have an x plus 1 plus, and then I'm going to write my partial fraction decomposition, which was the a over the x minus 4, so that's a 2 over an x minus 4, plus the b, which was a 6 over the x plus 2. So this whole thing is my answer. I need the x plus 1, even though it's not actually part of the partial fraction decomposition, because it wasn't part of the fraction when I was decomposing stuff. So there you go.